In this video, we'll be adding basic authentication to our services and also role-based authorization. We will have two roles: admins who can perform write actions such as creating an employee or payroll and updating or deleting it. And the other role would be a reader who can only read the data, meaning they can only perform HTTP GET requests. So Spring Boot allows us to easily integrate security into our application, and we can use different authentication schemes such as OAuth2 or JWT. But for this project, we'll be using basic auth. So basically, anyone who wants to use our application, they will have to log into our application. So the first thing we're going to do is we're going to uncomment this dependency out. So we're going to be adding this dependency Spring Boot to our security. And let's create a new package called security. And we'll create a class called app security in this. So Spring has a really nice documentation on how to incorporate Spring security into our application, and we're going to take a look at some of them and start following it in order to add authentication or authorization. So the first thing we're going to do is we want to add these two annotations. So we're going to head back to our project, and let's import these annotations. So this will basically pretty much allow us to enable web security into our application. So the next step we're going to do is we want to add authentication to our application. So we need to create a password. So we're going to use this bean on how to encode our password. So we're going to keep this very simple. We're going to use a no-op password encoder. And pretty much what this no-op password encoder does is it doesn't allow us to encrypt the password. So for example, if we're going to type in a password, let's say test, it's not going to encrypt that. Ideally, we don't want to do that in production or any other higher environment. This is just for testing. So another type of encoder that we can use is bcrypt, which is a very well-known password encoder scheme that we could use. However, we're just going to keep it simple. The next step we're going to do is we're going to create some in-memory users. So ideally, we should have a user stored in the database and have roles assigned to it, and then use this app security to figure out which user is logging in. But for now, we're going to create the user in memory. So we're going to create two users. We're going to create one admin and the other reader. And here we're going to call our encoder. And let's assign this role as an admin role. So before we actually assign a role, let's create an enum. So we're going to head over to our model, and we're going to create this class called enum, which will have user roles defined. And here we're going to create two roles, an admin and a reader. So let's create the next user. It's going to be we're going to call this a reader. So this user can only read the data. That's it. All right, so now let's return this new user that we created. Now we actually want to do the part where it's going to do the authentication and also perform authorization as well. Which user is logged in, what type of role it has. So we're going to follow this documentation. So there's a bean that we can use, which is called Spring Security Filter Chain. And this will allow us to perform authentication and authorization. So let's follow this. I'm just going to copy this part. And let's create this bean. So the first step that we want to do is disable CSRF. So CSRF stands for cross-site request forgery. And the reason we want to disable this is we're not using a browser, we're using Postman. And if you don't disable this, we won't be able to perform post requests inside of Postman. And another reason that we may want to disable this is if you're using a different token mechanism. So another step that we want to do is enable CORS. And CORS is pretty much stands for cross-origin resource sharing. And this is required by all browsers as they apply the same origin policy only. Pretty much what CORS does is if we want to allow requests from other domains or origins to be made to our service. So for now, we're going to allow all origins. And also just as a side note, anything related to security can be quite complex. And with Spring Security, there's a lot of fine-grained control that we have in terms of what methods we want users to have access to and how to properly secure our application. So security and especially Spring Security can be a pretty big topic. And we're touching the basics of it in terms of how to incorporate basic auth and authorization. If you guys are interested in learning about CSRF and CORS, I will leave a link in the description that explain the concepts really well. All right. So the next step that we want to do is we want to set up the authorization of request. So we're going to call this authorize request method. And we want to match only, let's say, HTTP delete, post, and put can only be performed by an admin user. So we're going to add authorization to those 3 post methods. And we're going to say if a user has a role of an admin, then allow this method to be executed, or allow that user to execute the delete post request. And we're going to do this for post and also for update, which is put. And let's do one more. We're going to say you know what, everyone has access to our actuator endpoint, which is pretty much the health check to see if our service is running. So we're going to say skip any sort of authentication or authorization for that. And to do that, we pretty much just say the path to our endpoint, which is the actuator. And pretty much allow any sorts of endpoints. So actuator has quite a bit of endpoints like actuator/health. I think there's /logs. There's quite a few of them. So we're going to say users have access to all of them. And for that, we say permit all. And also, we're going to say, since we're using H2 only for locally, we're going to say everyone has access to H2 console. Okay. And all the other requests need to be authenticated. All the other requests need to be authenticated. So we're going to add this authenticated part. And let's build this filter out. And let's return this. Okay, so let's test out our application. All right, let's see if you can post an employee. So right now, I don't have any auth set up. So I'm going to do no auth. So I should get an error 401. Yep, I got 401 unauthorized, meaning that I'm not logged in. I don't have access to this resource at all. So let's set up the basic auth. And we're going to use the admin. So now with an admin, we should be able to post an employee. Yep, so our employee got created. Let's try to post employee number 2. This time we're going to use the reader username. So with reader, we should get forbidden, meaning that this user shouldn't have access to this resource. Yep, so we got forbidden status code as well. So let's try to use admin. Our resource got created. Let's try to do get all employees. With admin, we got access to all employees, and let's try to use reader. So with reader, we have access to all employees as well. And let's do basic auth here. Okay, so employee is not found. Let's see if we can get this employee. All right, so our username, authentication, and authorization rules are both working. So now let's actually try to handle this exception and then be able to print out a friendly message to the user where they can read it easily. So for that, there's an exception handling that we can add. And we are going to create a new exception handling for if access is denied. So there's the access denied handler. And over here, we need to override or create our new custom access denied handler. So let's actually do that. So we're going to create a new class, and let's call this custom access denied handler. And this will implement this interface that we're going to override access denied handler. So let's build this out. So the first thing that we want to do is we want to set the response content type, and we want to return a JSON format. Next, we want to set the status. So this is going to be for the forbidden status. And now let's actually try to use our error message object. So for that, we are going to create a class or an object of object mapper type. So we can easily map this error message object and return that to in a JSON format. And we want to write the message back to the response. Okay, so our custom access denied handler is implemented, and let's try to use this. So we are going to create a new bean and kind of wire this up. And let's pass in that method. All right, so let's test this out. All right, so let's try to do the post employee, and we're going to use a reader username as a role. And so we should get forbidden, and now we should see our custom message over here. All right, there you go. So we actually got our custom message implemented. And we got the message saying access is denied. Let's do one more. What if the person is not authenticated? He's not logged in. So we're throwing the 401 unauthorized error. So let's try to print out the message for that. Now this is a little bit tricky because we need to throw this at an entry point. So for that, we need to override a couple of things. So the first thing that we want to do is we need to provide our custom authentication entry point. And for that, let's create a new class. And let's call this, we're going to be delegating an entry point. So let's call this delegated authentication entry point. And let's auto wire up our handler. So we're going to call, and this is going to be called handler exception resolver. And we are implementing the authentication entry point. All right, let's just try to resolve this error or this exception. And this is pretty much it, what we want to do. And let's label this as a component. And let's use our entry point. So we are going to auto wire up the class, and it is the delegated entry point. And let's just plug it in here. And now we want to override the custom exception or the custom message. So we want to override this. Again, we're going to go back to our control exception handler. And pretty much we're going to follow this example. And we are returning authentication exception class. And this is unauthorized. All right, so let's test this out. All right, so we got an error as primary. Okay, yep. So we need to tell which bean to use. So we need to add a qualifier to this. So with qualifier, we're telling we need to inject this bean in. So let's call this handle. This is our bean. Okay, so this should fix it. It's handler. All right, let's see if this works. All right, let's post an employee. Yep. All right, so we got our custom message. So we got full authentication is required by this resource, and we got the status code updated here as well. Okay, so to recap, we went over two major parts of Spring Security, which is adding basic auth and creating role-based authorization. We were able to enable basic security across our application. We also saw how to provide custom exception for both authentication and authorization. So this wraps up our employee payroll application, where we got REST API for creating employee and payrolls. We added security across our application and created roles which needs to be authorized against a particular resource. In the next and final video, we will containerize this application in Docker. And finally, let's just push our code to Git.